All right, so the reason we have been focusing on factoring in the last 2 days is so we can do what we're going to do today and what we're going to do tomorrow. And today we're going to simplify rational functions. And so a rational function is nothing more than a fraction in which the numerator and or denominator are polynomials. And so you might not know, but polynomials, pretty much all that stuff we've been practicing factoring, those are polynomials. So we'll have something like that on the top and something like that on the bottom. And so there's some examples of rational expressions. And then when I teach this, actually I used to, do you guys know Jackson Shimwell and Connor Shimwell? Their grandmother used to teach math. And so when I first started teaching, she was here and she taught it this way. And so I kind of stole it from her. And it's goofy and it sounds morbid, but it's just to be funny. It's not to be weird. Like this is not real people. So these are some weird things I say about rational expressions. One thing I say is that addition and subtraction binds terms together in marriage. So when after you factor, if you have, and even before you factor, you can always factor, but if you have something like x plus 2, the x and the 2 are bound together in marriage. If you have like x minus 7, they're bound together in marriage. If a term isn't added or subtracted to or from another term, it's single. So if you just have like a 2 by itself, not added or subtracted, then it's a single term. And if these terms are married, they live together and they die together, right? And they have to die when there's another couple like them on the other side of the fraction, okay? So let's look at what we do. So the first thing we're going to do is just anything that can factor, we're going to factor it. So I'm going to do like a lot of side work on these. So I'm going to start with over here on A, 6k minus 36. And the first thing we're going to do is just factor that. And to factor it, we're just going to factor out a common factor. So what do they have in common? 6. So we're just going to factor out a 6. And so we'll divide each of those by 6. So my new numerator is 6 times k minus 6. Now, if your numerator or denominator is just something like k minus 6 or x plus 1, it won't factor. So you just go ahead and bring it over. All right, so the k minus 6 is married. They're married to each other. And so they have to die when there's another couple that looks just like them. So k minus 6 has to die. So it just gets canceled out. And what are you left with? 6. 6 is the answer. Okay. Sometimes. Most of the time, no. All right, so let's look at this one. This y plus 8, it is not going to factor. So we're just bring it over. But y squared minus 2y minus 48 is going to factor. And because there's not a number in front of y squared, it's just like 1y squared, we're just going to factor normally, where we'll do our two parentheses. And then since this is a minus, my signs are going to be different, 1 plus and 1 minus. And then we want to multiply to get 48 and subtract to get 2 or negative 2. Can you guys think of numbers that would multiply to get 48 and subtract to get 2? Now when you're doing this, you're right.
7 times 4. No.
That's 28. That's okay. When you're doing this on your own, you can do that thing we did yesterday where you look at the graph if you want to, or you can look at that yellow sheet, but it's going to be 6 and 8. And so which one, since I want negative 2, which one do I want to be negative? The bigger or the smaller? The bigger. So we're going to have the 6 be positive. And you know what? I wrote the problem down wrong. Sorry. I actually want the 2 to be positive. So we're going to have the bigger number be positive. All right. Do you guys see anything that has to die? I know that's a weird question. Y plus 8 has to die. All right. And then if everything cancels out of the numerator, what's there? Oh, a y minus 6 is on the bottom. It's okay. What do you get when you divide something by itself? Like 2 divided by 2, what's that? 1. So it's just a 1. So if everything cancels out, there's a 1 up there.
So it's kind of like if there's an X in place. In a way.
Kind of, yeah. All right, let's look at the next one. So I'm going to take that numerator, 2r squared minus 2r minus 40. Make sure I write it down right this time. And I'm going to factor it. And so the first thing, especially if there's a number in front of the r squared, just check to see if there's a common factor. Is there a common factor? Yes, it's 2. So we're going to go ahead and factor out that 2. I feel like I've done this problem a lot. Thought x squared minus x minus 20 or r. So we're going to have different signs and then multiply to get 20 and then subtract to get 1 or negative 1. It's going to be a positive 4 and a negative 5. I'm messing up a little bit right now. Don't know why. But that is going to be my numerator. And then for the denominator, really the only thing I can do is factor out a common factor of 8. So 8 times r plus 4 is my denominator. Okay, so the r plus 4 has to die because there's one on the top and one on the bottom. Now, this 2, and this 8, they are single because there's nothing added or subtracted to them. So they don't have to look exactly alike for you to be able to reduce them. So I can just take 2 and reduce it, 2 and 8, and reduce them by the same number. Anyway, 2 over 8 reduces to 1 over 4. Okay, so on our numerator, we're just left with r minus 5, and our denominator is 4. So we're going to start D off the same way. We're just going to go ahead and take the numerator, p squared minus 49, and we're going to factor it. Now, if you don't feel super awesome about factoring, you might want to keep this guy out from the last couple days. But when there's 2 terms, there's 3 things it could be: difference of squares or the sum or difference of cubes. So what are these? Squares? Yes. So squares is easy. You just do your 2 parentheses. You find each square root, so p and 7, and you put 1 with a plus and you put 1 with a minus. Okay. And then we have the denominator, and it has 4 terms. So if you look at that factoring guide, when you're factoring with 4 terms, you're going to factor by grouping. So we'll divide it into 2 groups and factor a common factor out of each group. Right, and then after you do that, if everything works out, these should be the same. If they're not the same, something's wrong. Either I messed up making the problem out or you messed up factoring. But what you factored out goes in one set of parentheses, and then that p minus 7 goes in the other set. All right. And then p minus 7 has to die. All right. Now it's tempting, like when you see something like this, to think like, oh, I can just cancel out a p there, but you can't because of the plus and the minus. They're married, and so they have to look exactly alike for you to be able to cancel. So this is it. This is the answer. All right. Any question? Okay. We have several more. I have more examples than I have problems for you to do on your own today. All right, so on E, I'm going to take 12a cubed minus 3a, and I'm going to factor out a common factor of 3a, and that's going to leave me with 4a squared minus 1. And then that will factor again. So we'll find each square root and put one with a plus and put one with a minus. All right. Same thing on the denominator. It's going to be a little easier though. We're going to factor out a common factor of 6a squared. And then that's going to leave you with 2a plus 1. And that's all we can do for that. Oops. It should be 6a squared. All right. So 2a plus 1 has to die. Right, anything that doesn't have addition or subtraction, we can reduce without it looking exactly the same. So 3 over 6 reduces to 1 over 2. And then a over a squared, one of those a's can cancel out. It's just going to leave you with a in the denominator. Okay, so our numerator is 2a minus 1, and our denominator is 2a. Can I reduce those two a's? I know you want to. Can you? But you can't because this one's married. This one's married to a 1, so we can't reduce unless it looks exactly the same. All right, well, let's look at F. Really, the most difficult part of this is factoring. If you're super awesome at factoring, this is going to feel like a breeze. If you're not super awesome at factoring, then it's probably going to feel really challenging. Okay, so I just took that numerator, and anytime there's a number in front of the n squared, we still need to check for a common factor, and this one has a common factor of 2. Oh my goodness. All right. Now, inside of those parentheses is a trinomial, and there is a number in front of the n squared. So to factor it, I'm going to do slide divide bottoms up. So I'm going to take that 3, I'm going to slide it over. Then I'm going to factor normally for a second. So signs are the same, both pluses. I want to multiply to get 3 and add to get 4. That has to be 3 and 1. There is nothing else that multiplies to give you 3. All right, then we'll go back and divide by the 3 that we originally did the slide step with. All right, if it will divide, I'll go ahead and divide. If it won't, then I'm going to do bottoms up. Okay, and then for 2n minus 2, I'm going to start off the same way. I'm going to factor out a common factor. This one is going to be difference of squares. All right, and then I'll just bring that up, put it on the bottom of the fraction. All right, you guys finish this one from here, please. Okay, we're going to do a couple more together. All right, so I'm just going to take that 5w minus 45, and I'm going to factor out a common factor. All right, then I'll take 3w squared minus 28w plus 9. And because I have a 3 there, I am going to just kind of check to make sure there's not a common factor, but there isn't because 3 doesn't divide into 28. So because there's not a common factor, there is a 3 in front of the w squared, it's going to be slide, divide, bottoms up. All right, so I'm going to slide the 3 over. All right, so this time the signs are the same. They're both minuses. And I want to multiply to get 27 and add to get 28. What do y'all think? 27 and 1. Oops. Then I'll divide by the 3 again. Okay, so that's my denominator. All right, W minus 9 has to die. And we're left with 5 on the top and 3W minus 1 on the bottom. All right, one more. It's pretty quick, actually. Okay, so we'll start off with x cubed minus 8. All right, and again, this factoring guide is helpful because when there's two terms, it could be squares or cubes. This, because I have x cubed, is obviously cubes. And so for cubes, you're going to do a small set and a big set. And you find each cube root and then just kind of put them into the formula. All right, and then x squared minus 4. Uh-oh, I put a instead of x. Okay, so for x squared minus 4, it's the difference of squares. So we find each square root and do one with a plus and do one with a minus. All right, and then x minus 2 has to die. This is it. And even though I know it's really tempting to try and like cancel out an x or cancel out 2, you can't because they're married. The top actually is, I guess, like polygamy. There's marriage between 3 terms. Nobody likes my jokes. It's okay. All right. Any questions on this crazy stuff? All right. You guys have 6 to do on your own.